Alright children, in today's lesson we're going to look at using the distance formula on the coordinate plane. So first thing we're going to look at is how to derive the distance formula, meaning how do we create it, where does it come from, and then second, just using the distance formula. Now what the distance formula does is it tells us the distance between any 2 points that are on the coordinate plane. Alright, so it says in the previous activity, use number lines to determine distance and to locate the point of a segment. A number line is one-dimensional though. So right here we're going to look at 2 dimensions. When we have a plane, how do you find the distance between 2 points? So we're going to use the coordinate plane right here and follow the steps in each number to determine the distance between points P, which is 1, 4, and Q, which is 13, 9. So first step says to plot the points 1, 4 and 13, 9. So let's just do that together. I'm going to do it in blue. So we plot the point 1 over 1 and up 4. Right about there, and 13, 9 is right here. Okay, so we plot those points and then we draw PQ. So we're going to connect those with a segment as straight of one as we can. A little bit off there. Let's try again. Sorry, it's a little bit tough on this tablet to draw lines straight. Alright, so there we go. So we got P and Q. Alright, now part 2 says to draw a horizontal segment. Okay, horizontal means flat like this. Okay, vertical means up and down. So we want to draw a flat line segment PR and a vertical segment QR, right? So the horizontal one's got to connect to P. So it's got to be flat like this, PR, and then a vertical one, QR. So we want those 2 segments to connect at point R to create a right triangle, right? A right triangle meaning 90 degrees. So let's draw a horizontal line here and a vertical line here, straight up and down, and wherever they meet is the point R. So right around in there, that's point R. So we can erase the other part. Okay, so that is point R. So it asks for part 3, what are the coordinates of point R? So we can see the coordinates are over 13 and up 1, 2, 3, 4. So 13, 4. Okay, so for number 4, all right, use what we drew out there on the first part to answer questions 4. All right, A, B, and C. So go ahead and pause the video and give number 4 a try. Okay, so part A says, what is PR? The length, remember PR without a line over anything means the distance between P and R. So that's the length of the horizontal leg of the right triangle. And what is QR? The length of the vertical leg. So they're asking you how long are those 2 segments. So from P to R, how far is that? And from Q to R, how far is that? So for PR, you should have gotten that the distance from P to R was 12. And from Q to R, you should have got that the distance was 5. Okay, now how did you get that? Okay, that was the next question. It said explain how you determine your answers. So the easiest way is to just subtract the coordinates. So if right here is 13, is where R is, and P is at 1, well, what's the distance from 1 to 13? So you just do 13 minus 1, and that gives you 12. Same thing right here, but you do it with the y coordinates. R is up at 4, and Q is up at 9. So you just do 9 minus 4, and that will give you the distance of 5. Okay, so that's where those distances come from. Now the next part says use the Pythagorean theorem to find PQ. All right, so I'm just going to stay down here. All right, so Pythagorean theorem, something you should have done in middle school. If you can't remember it, it's a squared plus b squared equals c squared. And this formula always works on a right triangle. If you have a triangle that has that right angle, then you know a squared plus b squared equals c squared. And what these letters represent, A and B represent the 2 legs. That's the 2 sides that make the 90-degree angle. And C represents the hypotenuse. That's the length of the other side that is across from 90. That's your hypotenuse. And it's always the longest side. So we can use the Pythagorean theorem now to find the length of that third side, because we know what one side is, and we know what the other side is, 5 and 12. So let's plug 5 in for A and 12 in for B. 5 squared is 25. 12 squared is 144. Equals c squared. 25 plus 144 is 169. Now to get c by itself, we've got to get rid of a squared. To cancel a squared, you do a square root. And if I do it to one side, I have to do it to the other. The square root of 169 is 13. So I know now that the distance from P to Q is 13. Okay, that's the distance that it takes to get from P to Q. All right. So when question 6 asks us what's the distance between points P and Q, we can say 13. How do we know? The reason we know is because we found the length of PQ, right? We found that length is 13, and the length of PQ is the same as the distance between the points, okay? So that would be our explanation. We found the length of PQ, and that's the same as the distance between the points. Okay, 7. How do we know that the triangle is a right triangle? Okay, how do we know that it's a right triangle? Well, we know it's a right triangle because we drew a horizontal line and a vertical line. And by definition, horizontal and vertical lines have to make a 90-degree angle. And if they make a 90-degree angle, then that must be a right triangle because it has a right angle. Okay, so our explanation, I'll show you over here. Okay, easiest way to explain it. One side of a triangle is horizontal and one side is vertical. So these sides are perpendicular and intersect to form a right angle. And if they're a right angle, then a triangle with a right angle has to be a right triangle. Okay, and then last part, number 8. What relationship do you notice among the coordinates of points P, Q, and R? So if we go back and look at the coordinates of P, Q, and R, okay, something important to notice. Okay, remember P was the point 1, 4. Q was the point 13, 9. And R was the point 13, 4. Okay, so looking at those, pause the video and see if you can figure out what's unique about those 3 points, and then we'll go over it. Alright, so hopefully you noticed that for point P and point R, they share the y-coordinate. Both of their y-coordinates is 4. And for Q and R, both of their x-coordinates is 4. So that's hopefully what you noticed. That's what the answer says. Y-coordinates of P and R are the same, and the x-coordinates of Q and R are the same. Alright, so now let's see if you guys can do the check your understandings for 9 and 10. So pause the video, give these a try for a few minutes, explain how you could find the distance between those 2 points using the same method we just did. And then for number 10, actually find the distance between those 2 points. And then we'll go over it and see if you got them correct. Here's a sample answer for number 9. You would just go through the whole process, say plot the points on a coordinate plane, draw the horizontal segment just like we did and a vertical segment to create a right triangle. Then with the right angle at that vertex, also after that you're going to take the absolute value of the difference of the x-coordinates. So basically, when we say absolute value, basically just subtract the x-coordinates, okay? So if you said, instead of saying take the absolute value of the difference, you could just say find the difference of the x-coordinates or subtract the x-coordinates to find JL, and then do the same thing for the y-coordinates to find KL. Then once you know the horizontal and vertical distances, you can use the Pythagorean theorem to find JK. And the distance between points J and K is 10 units. And the answer for number 10 is 25 units. So for number 10, if you want to see the work, I'll put that, let's draw that somewhere. So if we've got 9, negative 5, all right, I'll just draw a rough sketch here. All right, so we've got the point over 9 and down negative 5 somewhere. And then we've got negative 11, 10, so way up here. So we've got this really long line. Okay, so we want to make a right triangle out of this. So I'm going to come all the way across horizontal and then vertical to make that 90-degree angle. So the question is, how long is this side? How long is this side? Well, let's think about the coordinates. This was negative 11, 10, and this one was at 9, negative 5. Okay, so just like the one we did a minute ago, these 2 points, okay, the one at the bottom of the right triangle and up here, they should have the same x-coordinate because they both go over the same distance. So this should be over at negative 11, and these 2 should have the same y-coordinate. So this one's at negative 5, so this one should be down at negative 5 because they're both below the x-axis the same distance. All right, so now to find the lengths of these sides, now that we've plotted our triangle, we want to find how long are the two legs. So the distance between 9 and negative 11. So we subtract 9 minus negative 11. We know when we subtract a negative, it really adds a positive, so 9 plus 11 is 20. All right, and then same thing right here, but with the y-coordinates, 10 minus negative 5. So again, we're subtracting a negative. That means we really add a positive. So that is 10 plus 5, which is 15. Now we can use the Pythagorean theorem with 15 and 20. So we would say 15 squared plus 20 squared equals c squared, where c is the side we're looking for, the distance between our points. 15 squared is 225. 20 squared is 400. That adds up to be 625. Then to get rid of the squared, you take the square root of both sides. Square root of 625 is 25. So I know C has to be 25 units long. All right, so go ahead and take a break before you watch the second part of the lesson and give your eyes a rest and then watch the second part. Thanks.